Okay, so we are doing Chapter 6, Section 5, which is going to be the graphing square and cube root functions. This is actually, I think it's pretty easy. It's no different than what you did when you graph quadratic functions, linear functions. What we just need to realize is that they're all pretty much the same concept. So if you look at the parent function means like the parent function of square root of x is square root of x. The parent function of the cube root of x is just cube root of x. And then basically what we do is, this is the basic function of square root of x, and then what we're doing is we are adjusting it from there. So this is the basic function of cube root of x, and then we're adjusting it from there. And now down here, when we're doing the graphs of radical functions, this kind of tells us everything that can change. So we can have a number out in front of the root, we can have a number inside the root, and then we can have a number on the outside of the root. And notice the same thing is true for the cube root. So it doesn't really matter. So what we're going to do here is when I graph this first one, my parent function is the square root of x. Now, you don't have to do this every single time, but what I'm going to do is I'm going to go ahead and graph what the parent function looks like. And I know this predetermined, this is what it's going to look like. Okay, and that's a curve. So this point right here is square root of 4 is 2. This point right here is square root of 1 is 1. And square root of 0 is 0. So there's our parent function. Now, what we're doing is if you look at this, our h and our k values down here, those are translations, meaning it's a shift. It's a shift on your graph either horizontally, left and right, or vertically up and down. So based on this minus 2, it's not underneath the square root. So because it's not underneath the square root, it's a vertical shift. Anything that's not underneath or with or in parentheses on our function, it's just kind of separate. What that's going to do is that's going to change our y values by minus 2, meaning it's going to shift down. So what we're going to do is our new function is going to be shifted down 2. So what we're going to do is I'm just going to literally take the points that I have and I'm going to shift them down 2. And then I'm going to draw my new graph. Okay, and that might not be perfect, but you get the idea. So make sure that you label that this is your square root of x minus 2. Now, when we do the domain and range, again, now that we're looking at a graph, it makes this, or it should make this, a little bit easier. If I look at my domain, what x values are we using? Well, my arrow is going this way, so it looks like we're definitely going to positive infinity, and we're starting at 0. So my domain is, you can either write all real numbers, or all positive real numbers and x equals 0, or you can just simply write x is greater than or equal to 0. Because this is what's defined, anything that is greater than or equal to 0. And our range, remember our range, if you recall, is our y values. So domain is x values, range is y values. So again, we are starting at y is equal to negative 2. And we're never going below that, so we're only going above that. And even though it doesn't look like that this will go up to positive infinity, it really will. It'll keep rising. So therefore, our range is y is greater than or equal to negative 2. So that should be pretty straightforward. I hope so. All right, let's look at the next one. So the next one is our parent. We're going to start with our parent's third root of x. So that's going to look like a point here, a point here, and a point here. And then it does something like this. And again, this does not have to be perfect. It doesn't have a curl like that. Okay, computer's messing up. Okay, so there's our parent function. Now again, this is on the outside, so all we're simply going to do is shift it by a positive 1. So we're moving everything up 1. And again, your curve does not have to be perfect. It's a general shape of the graph. and it looks pretty much the same as what we did below. Okay, and again, this top one, that is our third root of x plus 1. Now, domain and range here, these are really simple. Anything that is a third root or an odd root, your domain will be all real numbers and your range will be all real numbers. There's no restrictions. As you can see from the graph, we are going to go from positive to negative infinity with our x value, and our y value is going to go from negative to positive infinity as well. This will keep rising, this will keep falling. Okay, let's go to the next page. Same idea on both pages. Okay, so in this one, here's the idea. And again, I want you to make sure and I want you to realize, do the best that you can. These curves do not have to be perfect by any means. But what I'm going to do is, I know this graph is a little bit smaller, but the idea is I'm still going to graph my parent function. So I'm going to do square root of x, which is a curve that looks something like this. And again, it doesn't have to be perfect. Probably easier to do it with a pencil or a pen than for me with the whiteboard here. Okay, so there's our parent function. Now what we do is we look at what we have here. Well, I know that this plus 1 underneath the square root, that is going to be a translation. But now because it's underneath the square root, it's going to be a horizontal change. And now, the original, if you look at the front again, it shows something like this. A square root of x minus h plus k. So the one on the outside was our y, or that was our vertical. This one is our horizontal, but notice the original is negative. Therefore, if my h was 5 and the minus was still there, I would move it to the right 5. But because this is plus, we are moving it in the opposite direction. So therefore, I'm going to take all of my points and I'm going to move it 1 to the left. Left here, left here, and left here. And then I'm going to draw my new graph. And again, I know that it's not a perfect curve, but it should be a little bit easier. Notice the apparent graph, what I did was square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. That's where I got my 3 points. So then I just adjusted from there. Now, that is only if I take the plus 1 into account. So what I'm going to do is, because this is a little bit messy here, I am going to delete these for now. And actually, why don't we see if we can make this graph a little bit bigger. See if we can do this. So, again, my parent function is 0, 0, 1, 1, and then 4, 2. And then there was my curve. Now, I already showed you moving it to the left 1. Now, what does the 2 do? Well, here's the way you want to think about it. And again, you can use a graphing calculator for this. You can do the best that you can. But the original one, it goes up at a certain rate based on what square root of x is. What the 2 is going to do, because it's a larger number, is it's automatically going to change that rate. It's going to increase it. It's just like a slope. A slope with a higher slope is steeper. So what we're doing is we are definitely going to have this point right here. That's not going to change because our y value is 0. But with our other ones, you don't have to necessarily plot points, but just understand that everything is moving to the left, so the whole graph is shifting to the left. But it's going to increase a little bit. Now, we can do that. If we shifted this to the left and then we multiplied by 2, our new point will be right here. The reason why I multiplied by 2 is because of this 2 right here. So then again, we can take this one, move it to the left, and multiply it by 2. So then that's going to be up to 4. So we moved to the left, we're at y equals 2, multiply it by 2, we're at 4. So as you can see from this graph right here, if I can actually draw a smooth curve, it's still the same shape, but it does increase a lot quicker than what this one does. But it still has the same shape. That's the point. Okay? So let's look at the next one. Okay, a little bit, more difficult here. again, what I want to do is let's start with our parent graph. So the parent graph is just going to be our normal third root of x. We're going to do the best that we can here. So something like that. So there's our parent graph. So now what we're going to do is, again, let's think about where our points are. So we always start our points at 1, 1, 0, 0, and -1, -1, because those are easy points. We all know what the third root of those values are. Okay, so let me make sure that we have those points plotted a little bit better. So right there, and right there. Okay, so now when we do our new graph, the first thing that I'm going to do is I'm going to shift my graph. We're going to go down 3, and we're going to go to the left 2. Remember, this is opposite. So we're going to the left 2 and down 3. So that's what I'm going to do. Left 2, down 3. Okay? There's the first one. Left 2, down 3. Okay, and again, I actually just to point out, just follow along right here. Don't plot these points yet because we haven't done anything with the 1/2 yet. Forgot to tell you that. I apologize. So left 2, down 3. So this is what it would look like if we didn't have the 1/2 there. But what we can do now is I'm going to just go ahead and do a different color. We'll do it in black. So I'm just going to multiply all these y values in half. So 4 will now become 2. 3 will become -1.5, and 2 will become 1. And as you can see, again, it doesn't have to be perfect, but the graph is now going to become thinner or skinnier. It's not going to change as drastic. So when I do this, it's going to be a lot harder to draw a curve here. And again, you guys can use a graphing calculator to do this as well. And it's got the same general shape. I know it's not perfect. You guys will probably be able to draw it out a lot quicker. But the idea was, again, when you looked at this, it should be take your original parent function. You have your 3 points, 0, 1, 1, -1, -1. Shift it first. So that's where these points came from. And then what I did was I just took the new y values that I had and I multiplied it by whatever number I had in front. So this was 1/2 times 4, or -4, which is -2. 1/2 times -3, which is -1.5. And then 1/2 times -2, which is -1. And then I just plot my general shape from there. Okay, and again, it doesn't have to be perfect. Okay, so down below here, I'm going to put this back to normal. Down below, I want you to do this on your own. So try and graph this on your own with the principles we just talked about, and then bring it to class tomorrow. That's going to be what we start the class with to see how you did. So with the domain and ranges up here, again, we didn't go over that, so let me do that real quick. I apologize, I forgot about that. So here we go. Domain for this first one. If you look at your graph, the green is our graph. So therefore, we started at -1. So the domain is going to be x is greater than or equal to -1 because it goes anything greater than that. And then the y value, or the range, is going to be y is greater than or equal to 0 because we did everything above the x-axis. Over here, as I told you with anything that's to the third, our domain and our range is going to be all real numbers. So any third root will be all real numbers. I can't imagine that there's going to be very, very few exceptions. Obviously, there can be, but for what we're dealing with, this is all it's going to be. So again, do this problem. That's your homework on the notes. Bring that to class. That's what's going to tell me whether you really did this or not. So I will see you tomorrow or Wednesday, depending on when you watch this video.